Hi students, this is a little bonus video on graphing sine and cosine. So if you need a little extra practice, you can go ahead and do these along with me. So parameters, embrace the changes. So these are all the different things that are going to be able to happen to your sine or cosine graph. This A value is going to determine the amplitude. The amplitude is the distance from the midline to the highest point or the midline to the lowest point. If this is negative, so if A is less than 0, reflect across the x-axis. So that will tell you to reflect if that value is negative. Okay. Now we're going to take a look at our B value. Now the B value is going to help us determine the period. So helps determine period. Now what you want to think of here is PB, that relationship, the product is always equal to 2 pi. So PB equals 2 pi. So if we know B, we can go ahead and solve for the period. And again, this is for cosine or sine. Okay, let's take a look here at H. So this is going to be horizontal shift. So this is going to move our graph to the right or to the left, a value of H. And then if we have, let me get a different color here. Let's go green. Our K value is going to be a vertical shift. So that's going to move us up or down. Okay, so knowing all these things is going to help us when we're actually graphing. All right, these are the 3 functions I'm going to graph along with you. So if you want to pause and write these down, you can certainly try to graph these on your own and then follow along with me, or even check them on Desmos if that's easier. All right, so we're going to write down all the parameter changes that we can see. So when I'm looking at this right away, I'm seeing that my amplitude is equal to 3. There's no reflection. There's no horizontal or vertical shift, which means the midline is still going to be at y equals 0, which is the x-axis. It's a cosine function. I do see a b value of 1/2. So we're going to say, okay, PB equals 2 pi, and this works for cosine and sine. I'm going to go ahead and put in the b value, which is 1/2. To solve for p, I would multiply both sides by 2 and get 4 pi. And so 4 pi is the period. It will take 4 pi, that's the length of a complete cycle. All right, let's go ahead and see what we can get done here. Let's see. So we're moving up and down. So I'm going to go about here. And it's a distance of 4 pi. Okay, let me see here for the period. All right, so I think what I will do is I am going to actually make each 2 boxes a total of 1 pi. So 3, oopsies. This would be the 4 pi, 5, 6, 7, 8 pi. And then I think I'll do every 2 boxes is a value of 1 going up. So 1, 2, and 3. And this will be -1, -2, and I'm going to have to squeak in -3 down here. All right, so my midline is y equals 0. So this is my midline. And then the amplitude is the distance from the midline up to the highest point and the midline down to the lowest. So I'm going a height of this 3 here, 3 up from 0, and 3 down from 0. Okay. let's see, we're doing cosine. So let's go ahead and start plotting some points. There's no shifts to worry about. I'm trying to make sure. I think we got everything else that we need here. Let's go with green. Okay, so for cosine, there's no reflection or anything. So when we start a cycle, we start at the highest point and we end at the highest point. And notice I'm going from 0 to 4 pi because that's one full cycle. In the middle here at 2 pi, I go to my lowest point. In between the first 2 points is always sitting right on the midline. In between the last 2 points is always sitting right on the midline. And we can repeat this. So I'm going to go over to 8 pi to get one more full cycle. So we begin and end at the top, highest point. The middle is at the lowest point. And then we go ahead and sit right on that midline. Now you could certainly put points in and find these values. So let's say I put in pi as an input. So let's just take a look at why this works. So I say, okay, f of pi, that's going to be 3 times cosine of 1/2 pi. So we think about our unit circle. And here's 1/2 pi. This value is 0, 1. That's the ordered pair for that point. Cosine is the x-coordinate, which is 0. So this is 0, and 3 times 0 is 0. And look where I am. This is exactly where we plotted the point, pi, comma, 0. Now you could plug all these values in, all these different angles. And if you're not sure, you can certainly do that. But my hope is the more we practice this, you're going to see the pattern and you're going to be able to repeat that pattern using that knowledge. We're going to try to make nice smooth curves. And we know this goes forever and ever in both directions. So we have one complete cycle right there. And then we can keep going and going. Okay, I would also encourage you, use Desmos. So if you come up with something you want to try to graph, try it, type it into Desmos, and check your graph. Make sure you match. Okay, now let's try something with a little bit of different parameter changes. So for this one, I see that we are going to reflect across the x-axis. Okay, so I need to think of that. This is going to shift me, maybe I won't do an arrow here. We're going to go to the right pi over 4. Okay, so we have a horizontal shift. The amplitude is just 1. Okay, so that negative in front, it's a -1, so we are still going to go above and below 1. The midline, there is no vertical shift, so the midline again is just y equals 0, or that x-axis. Okay, so let's think about, okay, so I always take a look and try to think about how I'm going to scale it, because I want to make sure I can fit at least 2 cycles. And I want to make sure it's easy enough. If it was, let's say, right or left 1/3 pi or 2/3 pi, I would actually use every 3 boxes. Because then look how easy. Here's 1/3, here's 2/3. That would be much easier. But since I'm dealing with fourths, I think I'm going to go back to my 4 boxes is pi. So don't make it more difficult than you need to. I'm going to make every 2 boxes this way. 1. Okay. And it's reflecting. There's only one shift to the right. Okay, 1, 2, 3, 4. Let me get a couple more of these on here. 4 pi. Okay. So the midline is just still the x-axis, so nothing exciting. We had no vertical shift. We're going to go a maximum up 1. This we know from the amplitude. And the minimum, the lowest we're going to go is down -1 from the midline. Now, we're starting one cycle at pi over 4. So I'm going to make a little slice here just to keep my eye on where I'm at. Oh, and I didn't write here. The period is So PB equals 2 pi. The B value, B equals 1. So nothing exciting here. So the period is just 2 pi. Okay. All right. So we're going to go from 1/4 pi to 2 1/4 pi, because isn't that a distance of 2 pi? So really for me, I have 8 little boxes in here. Okay, now typically sine is going to start, have the middle and the end all on the midline, and that's going to stay the same for this graph, even though there's a reflection. If you reflect 0, it's still 0, so there's no other place to move it. Now, typically, oh, I did something wrong there, hold on. So this is the first and end, and then this is the middle. Sorry, be careful with that. Okay, and it definitely did not look symmetric, so you can see that something's kind of fishy there. Now, normally with sine, we bump up first. So instead of +1, if we take the opposite, it's -1, and we bump down. Let's see if I can, oh, I erased the whole thing. Too bad. Let me get that back on there. Okay, so in this case, since it's reflected, we bump down, then we bump up. And so this is one cycle of the sine curve. And I'm going to go ahead and do another one as well. So this is 2 1/4, which is going to go to 4 1/4. And then the middle is 3 1/4. We're going to bump down, and we're going to bump up. Again, you could certainly plug these inputs in and verify that you get those same outputs. Okay, so reflected sine function with a horizontal shift. Now the next one is going to have a little bit of everything. The only thing I didn't put in here is the reflection, but we just did that. So this is going to have an amplitude, which is equal to 2, okay, and that's from this. We are going to have, this is our B value, so I'm going to say PB is equal to 2 pi. I'm going to put the B in, so period times 3 equals 2 pi. Oh, this is even a little messier than I thought it was going to be. Perfect. The period is 2/3 pi. That's a fun fraction. And then we are going to say this shift is going to go to the left, pi over 2. And then we have this, which is going to go down 1. So now we have a new midline. Instead of the x-axis, it is going to be y equals -1. So we have a lot of things going on with this graph. All right, so let's see. We're going down 1, 2/3 left. Okay. And the amplitude is 2. Okay. So I'm going to put this right in the center because I think that'll still work out okay. We're moving to the left. I'm going to do it right here. There is no perfect way to do this, so you're just going to have to kind of play with it and see what works best for you. I'm still going to make every 2 boxes worth 1. Now, since I am dealing with thirds, I'm going to make every 3. Oh, and left a half. Oh, this is super disgusting. Okay. So we're just going to keep going. Let's just keep doing this. Okay. So we have, now I'm wondering, do I want to do this? I do. I'm going to keep going with these 3. Okay, this is going to be bonus messy because we're dealing with halves and thirds at the same time. So get excited. All right, we can do this. So let's see. Amplitude is 2. Midline. All right, so let's get in here what we need. So our midline is down here at -1. Okay, and we're going to go total up 2. And see, already now I'm regretting my axes, but that's okay. We're just going to keep going with it. And down 2, which means I have to be here. This is why I'm a little annoyed, but it is okay. Oops. Can I make it be straight? Woohoo, there we go. Okay, that's not so bad. Okay. Let's see here. So let me get this purple again. And let me go to the left. Oh, that's a little too dark. Okay, negative pi. Okay, so it says to start out this sine curve, left 1/2 pi. So get ready. So left 1/2 pi is going to be here. If 3 boxes makes a pi for me, then 1.5 boxes is the midway point, okay? The period is 2/3 pi. Oh, you're gonna love this one. So 2/3 pi for me is 2 total boxes. So that's gonna be here. So we're gonna jam this little function, this one little cycle right inside of here. Now let's make sure we did everything. We went down 1, okay? So that's our midline at -1. Let's see, okay, we got that. All right, the amplitude is 2. We're gonna go up 2 and down 2. Okay, very good. Sine function left 1/2, which is 1.5 boxes to the left. That's 1/2 pi. And then the total period is 2/3 pi, which means for me, 2 total boxes. If 3 boxes make 1 pi, that's how I've scaled it, then 2 of those total would be 2/3 pi. Okay, here we go. Ooh, this is especially gross. That's all right. Let's do this hot pink. Hopefully we can see okay. All right, so sine, remember, begins and ends on the midline. Now, it also has a midline point in the very middle. How great is this problem? Then we're going to go up to the highest point. We're going to go down to the lowest point. And we're going to squeak in this little curve. Look how skinny this is. And we're going to do it again. I'm going to get my blue line out, though, to make sure I have this down. So we want a total of 2 boxes, which means I'm going to here. Okay, let me get my pink again. So I start, I end, and I have the middle right here. I bounce up, I bounce down, and I curve. All right, way messier than I intended, but we are still capable of doing this. We need to take our time. We need to think about all the different changes. And again, as you're doing this, a great way is just to test it on Desmos. Pop in an equation, see if you can match it. All right, thanks for watching.